we have seen similarity means that the shape is the same and size need not be the same. So now let's look at this. We have a triangle and I want a similar triangle to this. What do? I know that for a similar triangle, only the size can change. The shape cannot. So I want a triangle which is either smaller than this or larger than this with this same shape. So what I decide is, I decided of projecting it on a screen with a projector. So I take a projector and I decided to project it on a screen. So that would give me a larger triangle of the same shape. So let's look at this. So you get a larger triangle. Now I know that these two triangles are similar. But further I want to see the properties of these similar triangles. So for that, what I'll do is, I'll first write the names of these triangles. Let me name these two triangles first. So let's say I call this triangle as ABC, the larger triangle, and the smaller one as X, Y, and Z. So let me call these two triangles as ABC and XYZ. Now I know that these two triangles are similar. So this is what I know, that both are similar. Or I can say, I can write it as triangle ABC is similar to XYZ. How do I write it? Note that X, vertex X is corresponding to A, Y is corresponding to B, and Z is corresponding to C. So A is corresponding to X, B is corresponding to Y, and C is corresponding to Z. So I can say that triangle ABC is similar to triangle XYZ. So one is either a scaled up version. I can say that this triangle is a scaled up version, is a larger image of this triangle. Or I can say that this smaller triangle is actually a scaled down version or a smaller version of this large triangle. So these two triangles are similar, or you can say a scaled up or scaled down versions. So now I know that the triangles are similar. I want to find the properties of these two similar triangles. For that, what I do is, I first measure the angles. So after measuring the angles, I get this. So I see that A, B, C of this triangle, angles of this triangle are equal to angles of this triangle. A is 37, X is 37. So A is 37, X is 37. Then B is 53, Y is 53. B and Y are also the same. And similarly, C and Z are also 90 each. So this C and Z are also the same. So when two triangles are similar, what I get is that the corresponding angles are also equal or also congruent. So I get A is equal to X, B is equal to Y, and C is equal to Z. So all the three angles are equal. Now, after the angles, what I'm left with is sides. So I measure the sides. Measuring the sides, I find this. So do you observe something here? We see that this side is 4, this is 12, 5, 15, 3 and 9. Do you observe a pattern? So 4 into 3, 12, 5 into 3, 15, 3 into 3, 9. So I see that whenever I multiply sides of this triangle by 3, I get this sides of this triangle. So what I can say is that AB, this side AB is actually 3 times XY. So 3 into 5, 15. So AB is 3 times XY. Similarly, BC is 9, which is 3 times YZ. 3 into 3, which is 3 times YZ. And similarly, this side CA is 3 times ZX. 4 into 3, 12. So I get this. With this, I can also say, if I bring XY from here to here, so since XY is multiplied here, if I take it to the other side, it would be dividing this. I'll have to divide it. So I get this. From this, I can write this. AB by XY is 3. Similarly, I can say, from here I can say that BC by YZ is also 3. And from the last one, which is CA is equal to 3 times ZX, I can say that CA when divided by ZX would also be 3. So I see that the ratio of the sides AB to XY, AC to ZX and BC to YZ, the ratio of the sides is the same. It's 3 in each case. So I can say that the ratio of the sides is the same. AB to XY is equal to BC to YZ is equal to CA to ZX. So when two triangles are similar, the corresponding angles are the same, they are equal, and the ratio of corresponding sides is also the same. So this is what I get when two triangles are similar. Now, let's look at this. We know when two triangles are congruent, all the angles are equal and the sides are also equal. So all the angles done. If all the sides are equal, I can say that this triangle is scaled by a factor of 1 here. It's just the size and the shape both are the same. Since the shape is the same, we can see this sign here which shows same shape. I can say that two triangles are congruent and also they are similar. Because the shape is the same, so I can say that they are similar. So congruent triangles are always similar also. But what about the converse? Of course, the converse is not true. Can I say when triangles are similar, they will be congruent? We've just seen that these two triangles are similar here. Can I say they are congruent? Not. Why not? Because there's a difference in size. For congruency, you need same size also. So these are similar but not congruent. So again, if things are congruent, then they are obviously similar. If similar, not necessary that they are congruent. And when two triangles are similar, I can say that the corresponding angles are equal and the ratio of the corresponding sides is also equal. So now, can you answer this question? We know that these two triangles are similar, that is given to us. What we need to find is the length of EF. So if two triangles are similar, then the ratio of the corresponding sides is proportional. What I know is that triangle ABC is similar to triangle DEF. If two triangles are similar, the ratio of the corresponding sides is proportional and the angles are equal. So we know the sides. So let's use that. We know AB and BC and DE. What I need to find is EF. So AB is what we know. So let's write AB by DE. This would be equal to, now the next side which I know is BC. BC proportional to BC is EF. So I can write this. Now substituting the values, AB is 12, DE is 3, BC is 8 and EF is what I need to find. So this is 4. Cross multiplying, EF would be 8 by 4, which is 2. So hence I can say that EF would be of length 2 centimeters.